السلام عليكم ورحمة الله وبركاته. Quantitative Methods in Accounting section, section 3. In this section, we will cover some exercise in coefficient of correlation and regression analysis. Coefficient of correlation or correlation coefficient formulas are used to find how strong a relationship is between two variables. The formulas return a value between -1 and 1, where 1 perfect positive relationship between variables, -1 perfect negative relationship between the variables, 0 no relationship exists between the variables. So values of correlation coefficient are around -1 to 1. When it is near to -1, so it is negative relationship. When it is moved to 1, it is positive relationship. This is the equation or formula to find the correlation coefficient, where R correlation coefficient, N represent number of variables, summation of x, y, the sum of x variables multiplied by y variables. Summation of x is the summation of x variable, summation of y is a summation of y variable, summation of x squared is a sum of a squared x variable, y squared is a sum of squared variable, squared y variables. Okay. Example, find the value of the correlation coefficient from the following table. We have table include some variables y and x. Exportation represent y values, production represent x values. How to find the correlation coefficient? The first step, draw a table, use the given data and add 3 more columns. Subject from 1 to 6, exportation, which represent y values, production represent x variables. Add another column for x, y multiplied by y, and another column for x squared and y squared. Step 2, multiplying x and y together to fill the xy column. For example, for subject number 1, exportation, which represent y, multiplied by production, which is x, 99 multiplied by 43 equal 4,257. Subject 2, 65 multiplied by 21 equal 1,365. Number 3, 79 multiplied by 25 equal 1,925. Number 4, 75 multiplied by 42 equal 3,150. 5, 87 multiplied by 57 equal 4,959. Number 6, 81 multiplied by 59 equal 4,779. So we get here x multiplied by y and put it in the xy column. Step 3, calculate the square of the x variables and y variables. X variable, let's start with x variables. X variables, which represented in the production, 43 equal 1,849, 21 equal 441, 25 equal 625, 42 equal 1,764, 57 equal 3,249, 59 equal 3,000 6,481. Step 4, calculate the square of the y variables. So, the same as x variables, we will do in the y variables. From 1 to 6, 99 equal 9,801. 65 equal 4,225. 79 equal 6,241. 75 equal 5,625. 87 7,569, and 81 equal 6,561. Then we will add up all the numbers in the columns and put the result at the bottom. So summation of y, which represented in exportation, 247, production 486, x multiplied by y, 20,485, x square 11,409, y square equal 4,002. So steps 6, we will using the formula to substituting by the values we will get from the previous table in the formula to get the R value. So from the table, summation of x 247, summation of y 486, summation of x multiplied by y 20,485, summation of x square equal 11,409, summation of y square equal 40,022. Sample size or n here equal 6. So the correlation of coefficient equal 0.529. The range from the correlation coefficient is from, as we said before, -1 to 1. The result is 0.529, which means the relation between the variables is moderate positive correlation. Now we will move to regression analysis. Regression analysis examines the impact of one or more independent variable on an independent variable of interest. Linear regression analysis based on a simple equation used y equal a plus bx. Those are the formulas used to calculate the value of e and b, where n is the number of variables, summation of y is the sum of y variables, summation of x is the sum of x variables, summation of xy is the sum of x multiplied by y variables, and summation of x squared is the sum of squared of x variables. Example, for the following data, estimate the production when consumption equals 16 million. Use the least square linear regression method. We have subject from 1 to 10, x values and y values. We want to estimate the production level when consumption equal 16 million. Let's start with step number 1, calculate xy and x squared. xy for subject number 1 equals 60, 2, 104, 3, 135, 4, 112, 5, 63, 6, 42, 7, 30, 8, 33, 36, 9, 25, 10, 25. Summation of xy equal 632. For x squared, subject number 1 equal 100, 2, 169, 3, 225, 4, 196, 5, 81, 6, 49, 7, 36, 8, 36, 9, 25, and 1025. Summation of x squared equal 942. So we will use these values, summations of x, y, xy, x2, and substituting in the following formulas for b and a. By substituting, we will find the b value equal 0.36, a value equal 3.26. So the equation will be y equal 3.26 plus 0.36. So we have the equation. We can use or substituting by using any value. In the example, we want to know the consumption when production equal 16 million. So x equals 16 million. We want to know the value of consumption or level of consumption which represented by y. So y equal 3.26 plus 0.36 multiplied by x. X substituting by 16, so y equal 3.26 plus 0.36 multiplied by 16, so y equal 9.02. So when production equal 16 million, consumption equal 9.02.